Welcome to the Syngenta Pest Talk Technical Tips. Today, we are talking about mosquito management because it is a hot topic at the moment. You may have noticed there's been quite a lot of wet weather in Australia, particularly today, even in Sydney. We're seeing more and more mosquitoes, and there's a lot of talk about mosquitoes as vectors of disease. You would have seen in the paper talk about dengue and also Japanese encephalitis. So we want to join Peter Ambrose-Pearce today, our technical services lead at Syngenta. He's going to host our Pest Talk webinar on mosquito management. So let me take you through the agenda. Today's webinar will run for 45 minutes. There will be a Q&A at the end to cover all of your questions on mosquito management. And in terms of the presentation we have today, it's really important that we first focus on identification and biology of the mosquito and understand their behavior. Pete's got some really interesting facts around that. We'll also see a video from Amy throughout as well. Next, we're going to talk about inspection and mosquito management plan, discuss the various different treatments. There's larvicides, there's thermal fogging. There's also vector spray application or adulticide, which Pete will take us through. We have the chemical application challenges to discuss, and then we'll also share a university study with you. And that's great because it's particularly local as well in far north Queensland. Followed by that, I'll host a Q&A session. And so we'll kick off now and hand over to Peter Ambrose-Pearce.
Hi, Carol. Thanks very much. And thank you, everyone, for joining us. There'll be a lot of people out there that may be trying to get into mosquito work or get some tips, but there'll be a lot of people out there maybe using this as a bit of a refresher. So sit down and enjoy the journey, and I hope you all get something out of it. So I'd like to talk a bit about mosquito biology, about the basics of life for the insect. We know that fertilized eggs are laid by the female mosquitoes in most instances in a body of water, which the larva will develop. The females carefully select this site according to temperature, salinity, and oxygen levels. The embryo and the egg completes development in 1 or 2 days, dependent on temperature. But the eggs are laid in water and the embryo emerges, and this is the first instar of the larvae and commences larval development. However, in those species that are drought, resistant eggs, and the embryo remains in the egg until it is next submerged in flood water, or it actually rains and gets some, high level of moisture in there to get those eggs on the move and on the hop. While mosquitoes need water, the type of water needs vary from species.
Sorry, Pete, let's skip forward to, beg your pardon.
Sorry, just
with me for a moment. There you go. Thank you.
While all mosquitoes need water, the type of water they varies between the mosquito species. Some species need fresh water, some need salt water, and some mosquitoes prefer highly ephemeral habitats, which are those water habitats that just maybe last a day or so. They may not be there again for another month or so, but those ephemeral places, and others will tolerate polluted real habitats. From coastal rock pools to snow melts, alpine streams, and the other habitat between, you can find most of the mosquitoes. Some of the most common and often nuisance-biting pests are Aedes, Caelis X, and Anopheles, and Aedes nodoscriptus, commonly found in urban habitats around Australia. Now, these insects, we'll go in a bit later, that not only bite in the morning, but some bite in the evening, and some actually bite all day. So we've got to look at the species identification too, which is very, very important. Mosquito identification. There are over 500 different species of mosquitoes in Australia, a number of which are serious pest and disease carriers, these vectors. Others are essential to our ecology, and some even are totally harmless to humans, pets, and livestock. In the Lockyer Valley, they have a species called false mosquito, which swarm like normal mosquitoes around lights and windows and stuff, but they do not bite. So they're not even an effective human insect or pest. Effective mosquito management can help minimise the public health risk and impact on amenity associated with mosquitoes. Mosquito lifestyle. The eggs, different species of mosquitoes deposit their eggs in specific habitats. The eggs are deposited either singly or in moist soil in the form of rafts on water surface. And these eggs are usually laid in groups ranging between 100 and 400 eggs. Within a few days, the eggs hatch into larvae. The larva wriggler molts 4 times over the next several days. The mosquitoes are called instars between these molts. So they're 1 to 4 size instars. On the 4th molt, it changes into a pupa. The pupa cannot eat. It breathes through 2 tubes on its back. The adult mosquito develops inside the pupal case, and in 2 days or so, when it's fully developed, it splits and the pupal skin emerges as an adult. The newly emerged adult rests on the water's surface until it's strong enough to fly away and feed. Behaviour. Activity is controlled by temperature, humidity, and light. Mosquito, low temperatures below 20 degrees Celsius inhibit activity and control control of tropical insects. But the same species may still be quite active at 15 degrees Celsius or lower in the south. Generally low humidity, below 70% relative humidity, are not conducive to moderate to high mosquito activity. Dense air aids in the mosquito movement or flight. So the mosquito activity to our species can be separately categorized as diurnal, active during the day, crepuscular, peaks of activity at dawn and dusk, and nocturnal, active during the night. So different species have really, really different behaviors and biologies. Reproduction, females need only mate once, but often mate more frequently. On mating, the sperm in the form of a sperm plug are transferred into the female and then migrate to the spermathe. There they are stored until required. When the mosquito is ovipositing, the sperm enters the egg and passes down the genital tract. One mating provides enough sperm to last the insect's lifetime. Feeding and host. Both male and female mosquitoes rely on plant nectar and plant juice to supply the carbohydrates needed to provide the energy required for flight and other activities. Female mosquitoes require blood meal to provide the protein needed in their mature eggs. Some of the species are very selective and only feed on particular vertebrate species. Others will feed on almost any warm-blooded animal, while other species will feed on cold-blooded like lizards and frogs. There are several stages of feeding the behavior. Activation. At the time of activation is set by the insect's biological clock, but will be modified by climatic influences. If it's too windy, too cold, or the humidity is too low. Orientation. Targeting or locating activities. The activity is often triggered by CO2, with the insect finding the host by flying up the odor plume generated by the host with CO2 and body odors. The number of authors lists the range of attraction at approximately 20 meters with a visual range of 7 meters. And landing and probing. The final stages of landing and feeding require visual cues of odor, color, and shape, as well as the odor plumes from our CO2. So with that, I'll hand back over to Carol to introduce you to an ambassador of Syngenta.
It's Carol from Syngenta back again. Let's see the latest from Amy and learn some fun facts about mosquitoes.
Hi, Amy from Syngenta here, and today, just for a bit of fun, I'm going to share some facts about mosquitoes. First up, and this surprised me, but it's actually only the female mosquitoes that bite, and they feed on our blood to help produce and develop their eggs. When you think of the world's deadliest animal, you probably start to think of sharks or crocs, but it's actually mosquitoes, as there are so many worldwide and they spread harmful diseases. Mosquitoes are known as vectors for disease like malaria, Ross River, and dengue, which are responsible for around 1 million deaths per year. Another interesting fact is that mozzies love CO2. They use a special organ called the maxillary pulp to follow the smell of the CO2 released from our breathing to locate their next meal. And a bonus fact, pregnant women produce 20% more carbon dioxide, making them a much more easy target for mozzies to detect. Not such good news for beer drinkers, but a 2011 French study found drinking 3 beers can lead to 30% more mozzie bite. And finally, mozzies need very little water to lay their eggs, so it's important to get rid of anything that can accumulate standing water, like empty pot plants, so best to store these upside down.
Some good tips there from Amy on a little bit about behaviour of mosquitoes and what makes them different. Inspection of the area to be treated is really, really important. We are treating an area that the mosquitoes are coming into. We're not spraying the mosquitoes directly as they come into an area. We're affecting an area or treating an area that they come into and pick up the insecticide that's been put down. Different mosquito species have different breeding habitat requirements. As we said, they lay their eggs on or near a water source, which can be either fresh, brackish, or saline, depends on the species. They prefer standing water, both natural and or man-made water bodies. Natural habitats include salt marshes, lakes, creeks, swamps, ground pools, irrigation ditches, and runoff channels. Tree holes and succulent plants, and leaf axils, the crevice formed between the stem of a plant and leaf. We get a lot of people in gardens and nurseries who breed things like bromeliads, and they hold that water in around that leaf axis, and that causes a constant area where mosquitoes really do breed, and we have to look after them in those areas. Inspecting the area to be treated. In urban environments, particularly backyards, mosquitoes breed in a range of water holding containers, notorious for people storing things behind sheds and garages. The removal and maintenance of these sites can significantly reduce mosquito numbers. Pot plant drip trays. Good one for there is to tip the water out, fill it full of fine-grained sand, and then put the tray back around the edge so there's no water on the edge. Septic or rainwater tanks. There can be some treatment supplied direct to those septic and rainwater tanks. Roof gutters. You know, someone's actually gone up and hit a cricket ball up on the roof and they've pulled the gutter as they're trying to get so it takes the fall away in the gutter. Ponds and ornamental water features, natural places where people breed fish that may not actually eat mosquitoes can actually breed mosquitoes. Disused containers, poorly maintained swimming pools, dog water bowls that haven't been utilised for a while, and especially disused car tyres and white goods. Those car tyres, we can never get them enough to get them flat, to not get any water, and they're black, hold warmth, hold moisture, and that's a part of it being a very good habitat to everyone. Remember treating an area. We're treating this place where the mosquitoes are coming in. Our application is an area which the target species enters and to be affected by the applied chemistry and methods control. It's essential to have a mosquito management plan. There's no point going in and just spraying and not having a plan of what we're going to do. Whether we're going to use larvicides and IGRs or BTIs, the adulticides, residual or spray sprays, and of course exclusion controls, netting and environment controls, removing those water sources. It's essential we have a management plan. Mosquitoes play an important role in the ecosystem. It is always important to minimise the impact of the environment when considering the need for mosquito management and choosing the most appropriate management strategy. It's important to obtain existing information, undertake baseline adult or larval surveys, analyse any available local government area information, determine essentially the customer's budget. There's no point deploying a plan that's going to cost thousands and they've only got a few $100s to spend. And evaluate the ongoing efficacy after you've done treatments. Many open spaces and areas and public parks and wetlands have an official conservation status at either local, national, international level. Always check whether approval is required before you undertake a mosquito management plan, even to the adjoining private properties or treatments that have limited results due to the adjoining properties will harbour and support insect populations. Advice should also be sought by the EPA or local government authorities prior to any application or treatment. Off-target species may also be affected. Native stingless bees. Some domestic gardeners are successfully breeding and supporting these populations. Be aware of the environmental impacts and even downstream for fish and crustaceans when applying chemistries. Larvicidal treatments are effective over a large area, particularly if applied from an aircraft, helicopter, etc. They're a sand-based carrier. Mosquito-specific can have a minimal effect on the environment, usually non-scheduled, and liquid formulations can be easily applied with watercraft-based spray equipment. Some BTIs, etc., available in slow-release block formations. So attacking them before they become adults, before they're becoming a problem, is essential part of vector management. A really good part to play in all these places. Adulticides. Large areas can be covered relatively quickly. Rapid knockdown with almost instant results with nuisance mosquitoes and disease carriers. Infected mosquitoes are taken down quite rapidly. We see drastic numbers reduced in population and people are not getting as bitten as much. Penetrates the nesting and roosting sites of dormant, resting and active populations, and is used to reduce the population of mosquitoes to breed, and with the larvicidal treatments have missed or failed. In the shadows of trees and other places where we can't get those larvicides with aerial applications is an area that we can do adulticide spray applications. Treatments like thermal fogging and spray cabins, not considered environmentally safe by some people. Drift of poisons and smoke considered dangerous and unsightly. Used as a cheap broad-scale application when plague proportion treatments are required, and as many considered, the smoke dissipates or kills the target population. It's a visual aspect. It works very, very well, but in the environmentally concerned area, we have to have more and more environmental controls on people entering those areas as it's being applied and sprayed, like we do with adulticides. We have to be very cautious of the areas. One chemical company actually brought out a clear thermal fogging liquid. It was working pretty good. It was used in the Pacific Islands, but unfortunately, the local government areas over there, and one of the ministers said they're spraying nothing because they couldn't see it. So they actually asked the guys to add diesel to the fogger, so it actually did create smoke, so people were knowing they were doing a mosquito treatment, which wasn't needed, but unfortunately it's that visual aspect of what some people consider being a treatment and being efficacious if they can see it, and some people don't want to see it in this day and age. Treatments and low wet mist spray applications. Ultra low volume is really, really important part of adulticide application. Targeted through the application, it's low concentration of chemicals, which is very economical. High residual efficacy for longer term treatments, up to 14 weeks. And when you use demand 100 CS, I'll go through that shortly. So it's actually showing a fair bit of efficacy. We're actually using that ultra low volume fogger to get that part really well working around, getting to coat the vegetation. 2016, we got registration for foliage application with demand, and now that's transferred over demand 100 CS to give it that highly efficacious treatment that gives up this treatment up to 14 weeks. I'll show some good data from that James Cook University study towards the end. So we're getting that air flying around with the droplets spraying onto the foliage to get this efficacious treatment. Silo or Mosquito type backpack mister blowers. Really, really good volume, push out a lot of air, an average of 12 to 15 litres per normal sort of Aussie backyard house, an average 20 to 25 minutes. The treatment is on average, can be around anything from $200 to $500, depending on the amount of foliage, but it's a good idea, a good add-in to your treatments to give your customers. We've known in this time of COVID that people weren't traveling, so they claimed back their backyards. They went to Bunnings, bought the outdoor settings, they utilised their pool, they made a gazebo, they weren't allowed to go anywhere. So people have really come back to using their backyards. And then they were, working out that this was a nice place to be. So when we're getting this treatment happening, we're actually adding to people's lifestyle, which is really important these days. The air disturbance, the application, the air disturbance is important rather than just using power equipment, because that foliage being rotated gets a coverage of the insecticide on both sides of the surface. The bigger droplets, that actually cause a mist particle. They're blown in there and they actually drop in and then crescendo. They break open and splash further and deeper into the canopy of the foliage or the trees. And this impact creates further dispersal. The treatment was more thorough than just power out equipment, as I said. And I usually treat from the outside towards the house. So I treat from the outer edges of the perimeter, treating those surfaces back towards the main structure that I'm attacking. So that's what I'm really protecting, that area where the people congregate. And as the insects come into that area to come and get that CO2 feed and meal, they actually pick up that, CO2 pathway where the people are partying, where the lights are on. And actually that's when we get the efficacious treatment because of that application with the mister blower rather than just our power equipment. Going to now demand technology, this capsule formulation. This absolutely brilliant chemistry with this ICAP technology. It's a synthetic pyrethroid, like most synthetic pyrethroids, but this is encapsulated. It's the M&M's technology. The chocolate melts in your mouth, not in your hand. It protects this SP really, really well and allows it to crack open at different times. There's different size molecules. It's really good for residual surface treatment. Smaller capsules will really go well on high polished surfaces, and the bigger capsules really on porous surfaces and brick and those sort of concrete, but it's really good across the board and will work on foliage as well. The capsule size is optimized for pickup by insects. This sizing is really important. Too big, the insects won't pick it up, vice versa. Too small, they'll walk over it and won't, pick it up with their proboscis when they land or on their feet pedestals. Long outdoor residual, the outdoor living area treatment can be sprayed and we can get good residual. We're not going to get great residual in heavy downpours like we've had in the East Coast over the last, with these rain depressions and the tropical, East Australian lows for 4 or 5 days of constant, 100 mil rain. So we've got to be realistic. But in normal rainfall areas, whatever, we can get up to 14 weeks of mosquito control when we're trying to apply direct to foliage. We even recommend in our marketing that we see some good results up to 10, 11, 12, 14 weeks, but we recommend a retreatment. You don't want to get the insects building up numbers over the last 2 or 3 weeks and the customer being dissatisfied. By recommending another treatment at about 10 weeks, we can get good ongoing treatment, especially up here in Queensland and Darwin and northern Western Australia, where the winter months are really quite warm and people are still using their backyards.
Hi, I'm Amy from Syngenta. Demand 100 CS knocks down ants, houseflies, spiders, silverfish, German cockroaches, American cockroaches. What? Where? Oh, I see him. And mosquitoes. Proven for up to 14 weeks, perfect for mozzie-free outdoor living. And it's plant and shrub friendly too. High five to that. Demand 100 CS. Complete long-lasting control on all outdoor surfaces. With ICAP, give mozzies this slap.
Demand 100 CS has a transfer of the toxic dose. The lambda remains in capsule when sprayed on a surface. The encapsulation protects it, helps bind it, and the lambda-cyhalothrin insecticide passes on to the mosquito cuticle when it contacts the capsule or picks it up from a treated surface. When they land, they pick it up, good covering of the surface. From the cuticle is rapidly transported to the active site in the insect, and one capsule, as you see there in the left-hand green square, is enough to kill a mosquito. Just that smaller part of an insecticide is enough on its cuticle to make it be effective over the next couple of hours to kill the insect. Of course, mosquitoes also touch the proboscis on the surface they land on, and they also ingest it into their stomach as they put their proboscis down on the surface each time they land. So really a bit of a double whammy of how to get them to really treat those surface areas. Perimeter formulations. Perimeter surfaces can be aggressive to insecticides. UV, concrete, wood, metal, cladding, bark, all those sorts of areas. We've got porous surfaces where you have to get these insecticides on where the insect will nest and roost. It actually happens to be a part of that insecticide that works well. The microcaps protect the active ingredient for a long residual. You can see here on the right-hand side, we've got some of the caps that actually start to crack and gradually go open. Then we've got some smaller ones that start to have smaller indents, and those indents are saying those capsulations are starting to crack. So this is where we get the longevity. It's not out and about in the environment all in one hit at the start and being really strong for the first couple of days up to a couple of weeks, and then all of a sudden we're getting no residual. This gradually cracks open. The bigger molecules with more ICAP technology crack 2 to 3 weeks later. So we're getting this longevity. So this is what pushes out the SP and lambda-cyhalothrin in demand 100 CS really full and further. So the smaller caps release earlier and the larger encapsulated droplets results in a longer, slower release, gives better UV stability. And again, as we said, 100 CS can be applied to foliage. It doesn't give that phytotoxic burn, which some people are worried about their plants. Of course, we also have to worry about the plants we're applying to. Be aware of evergreens and deciduous trees. If they're evergreen, we'll get problems, not many problems, but we'll get constant better things. But we're getting deciduous trees where leaves are dropping off. That is actually treatment. I'll discuss that a bit later in the university study, that this treatment actually drops off. So we don't have as much residual up there because the leaves have fallen on the ground. So we've got to look at realistically, and also new foliage. When that grows back, that isn't treated as well. So new leaves that grow in that 10 to 12 week period haven't got it. And if an insect lands on it, because it's not coated, will actually have no actual insecticide on it, of course. So here we can see a close-up shot of bifenthrin when it's actually applied. The bifenthrin molecule is actually down on the left-hand side here. It's been sprayed. It's cracked. It's open. It's efficacious for about the first 3 to 4 to 5 weeks, but then it starts getting broken down from the start. It's not protected at all. So this is why we don't get longevity out of bifenthrin. So that's a suspension concentrate to see how it's actually applied, but demand 100 CS. Here's these bubbles of the ICAP technology. Some are cracking open, some are starting to crack, the smaller ones, the bigger ones. They're in different sizes, multiple sizes for multiple insects. So this is why it's a very good broadband outside GP insecticide as well. Good for ants, good for spiders, good for flies, good for mosquitoes, great for spider work and stuff like that on your rural properties. So understanding this molecular protection of the ICAP technology with lambda-cyhalothrin really helps us in getting efficacious treatments. Here's a microcapsule actually diffusing on the surface of an insect. It's actually lodged onto the outer part of the exoskeleton, but there's this oil protective layer on these insects. So as you can see, the microencapsulation ball has actually linched onto the insect's exoskeleton, and you can actually see the lambda diffusing between the oil layer, the subcutaneous oil layer that protects the insect to its skin of the exoskeleton. So it's really, really important to see. And that droplet is just enough to kill the insect. It doesn't need 50 of them or 20 of them or 10 of them. Once it's got it, that's got its lethal dose, and that lambda, or the synthetic pyrethroid, will now go and do its job. Of course, we've got to have some challenges. Always consider rainfall forecasts, past and pending. There'd be no point doing a vector management spray today in New South Wales, as I think Nicole alluded to the weather with her internet problems. When we're getting rain impacts like this, there's no point in regularly doing those things. We have to watch out for things like then. If we're doing larvicidal treatments, we may be washing the larvicide away. We have to really target these with knowing tides, knowing rainfall forecasts, and understanding that it's a part of, we are treating the environment, so the environment plays a good part of it. We can't expect efficacious treatments if they're being tested outside of the parameters of what they're going to. Considering wind direction and neighbouring environments. We have to consider neighbours that may be environmentally friendly and don't want chemicals around. We've got to consider wind that may blow the treatment away from the actual area we want to treat it. Supplementary local government authorities and landowner treatments or non-treatment. Getting the local government or local council involved in what treatments they do around their streams in their local areas, as we see here in southeast Queensland. The Brisbane City Council are very, very proactive in vector management here. Doing probably 11 to 12 helicopter deployments, but also their monitoring stuff with their local pest management unit is very, very efficacious. We see a lot of those guys around doing proactive work, and it's good to see. Species identification and behaviour. It's important to know what we're treating. I had a pest controller ring me and they say, why am I getting only bitten in the morning for mosquitoes at 4:30, 5 o'clock, right on dawn? Well, he was sitting in his own backyard with a bright, device in his hand, and that was attracting him. He was out in the afternoon, but the species weren't biting in the afternoon. They were a different species that didn't have to do that. So we have to have species identification, and the behavior of each species is important. If we know how to they live, it makes it a lot easier how we can kill them and control them. The customer budget, of course. There's no point putting out $1,000 to $1,500 treatment if the homeowner hasn't got that money, or sometimes you might offer a $200 to $300 treatment, but the homeowner wants more and you may miss out on that work. Alternative supplementary control measures, of course, the exclusion, taking away those places of water being around, the brilliards, as I've said, talking to gardeners and homeowners, getting the pots and pans and things, the old water troughs, the old bath behind back of the shed, those sort of things taken out for control. And then also increasing stuff like predatorial fish control, adding fish to ponds, or mechanical controls, adding screens and or light traps. Very important. Light traps are a very, very important part of vector management, and in big commercial areas, they're an essential part of that. And the types of surfaces being treated, as I said, evergreens, deciduouses, or if it's flood prone, if it's inundated with water or tidal flood, we have to look at those floods because they can actually, on the king tides, they can actually raise up the tidal water on the reeds, and that's what hatches the eggs. And that's what a lot of vector management is around. This is a foliage treatment for up to 14 weeks for mosquitoes. So we have a trial here done by the University of James Cook in far north Queensland with the guys from Department of Health. And this was a paper written by Odwell Mazzari and others. And it was an efficacious treatment of how we had demand being used and utilised on foliage. So what we have in the blue dials is the mosquito reduction in the field. So we're seeing the actual application of post-spray in the weeks post-spray. We're getting 100% control in these areas of the chosen area for a number of weeks. Week 4, we had a bit of an inundation of some water and some rain, so the mosquito activity was down a bit because it was actually impounded by rain. But then we go across to week 8 to week 10, and we then get some numbers coming down. Of course, we might get some rain around week 10. The numbers pull up again, so we're getting some more adults. We're seeing the demand keep knocking over. And this is a sweep net counts. So we're actually going and making sure the mosquitoes are actually in the area, but we're still getting the traps, and we're also getting the counts of the mosquitoes when they're done in the field. The grey line is where we've collected the leaf matter off the ground after we've done these treatments. And we've then taken that back to the lab, and we've set that up in a meter cube plastic box that is actually then we associate mosquitoes for 24 hours with, and they go down and nest and roost on those bits of foliage or whatever because they don't like being exposed on the plastic. So they go down there and they actually pick up the insecticide. And we can see here, even after 14 weeks, with the residual just on the leaf litter alone, in those controlled spaces, we're getting up to 14 weeks. But this is why we say, like, we recommend keeping the customer happy, go out and get them actually doing a treatment again at every 10 weeks. They only have to do 2 or 3 treatments over a summer to enjoy their backyard most of the year round. The rest of the time, the mosquitoes are down in numbers, apart from in northern parts of, from Brisbane across to sort of Broome and north. We get a good control of those areas, those things. So this mosquito show and that mosquito essay just so this treatment was work, and the residual we actually do get once we do collect leaf litter and being around the environment of the trees, we're actually out with the sweep connections. Here's a field trial also done by Odwell Mazzari and others up there in Cairns. And we have the first 4 weeks prior to treatment of this line and dotted line on week 4. So we've got 2 similar areas, which are similar populations of same species, so similar numbers, but same species of mosquito. And then we're actually getting the control, the blue control. We're not doing any chemical treatment in that area. We're making sure the numbers and the natural environment's keeping those numbers across. And that course goes to week 18, but that's from start of the survey, which is actually 14 weeks after treatment, because we've got to take 18 from 4. So we turn around and we come back with 14 weeks of treatment. And on the day of application, we start the counts. And you see in the first week at week 5 on the 7th day, when we do the counts, the numbers are drastically reduced down to 0, 100% mortality to the best part we can do with the counts. Week 6, week 7, so 3 weeks post-treatment, 4 weeks post-treatment. We had a little bit of rain, so it gets the numbers up, or we get a bit of wind that comes in, blows a few mosquitoes from the alternative areas around. Again, the demand starts working, kicks in, really knocks the mosquitoes over. Then we get inundation about week 10, 9, we get the inundation of rain. More insects are actually hatching, coming out, but then the demand knocks them over again for a week. So we're getting some good trials, but here we see from week 15, so this is actually now week 11, 12 post-treatment, that is starting to wear out, and we're starting to get a bit of growth, but we've got the numbers going back in the control as well. So you can see these similar spikes in the control area where demand has kept knocking them back down, knocked down again, and doing efficacious treatments with backpack misters. So in a nutshell, it works really, really well. They're geared up to it and been onto it for a long while, and that's why we developed 100 CS from the old demand to make it more economical against chemistries like bifenthrin, to spray for mosquito control, but also general pest control. Bit of an innovation to help support people doing efficacious pest management, especially with flying insects. So in summary, the mosquito identification and biology is really important. Inspecting that vector, knowing where we're going to apply, if we're going to use a BTI, if we're going to use a larvicide, if we're going to use an adulticide, or a combination of all those areas. Light traps, the treatments, what we're going to actually be doing, the vector spray applications, how efficacious we can do it properly with a backpack treatment. Similar things with thermal fogging. That may work, but unfortunately, we've got to worry about what our neighbours or their neighbours will say when they see big plumes of white smoke coming across. And the chemical application challenges of what we have to do, looking at tides and floods and rainfall and the different types of trees that are in the environment we're having to look at. And of course, we've backed it up with a university study from the guys at the University of James Cook University. So very, very good, efficacious way of doing treatments. And I hope you guys have actually really enjoyed a bit of this. It's a brief talk. A lot more information can be gained by contacting us at Syngenta. But I always say inspection is absolutely paramount, as well as identification from the outcome and get-go. If we're spraying in the afternoon for mosquitoes that bite first thing in the morning, we get a rain pending in the night, we've got to look at that identification and also that environment. Really, really be careful of our neighbours, the people around, people's expectations of what we're doing. But we can get back into their environment and get them back into their environment and getting them enjoy their backyard. I'll stick around for the Q&A. So if there's any questions or whatever, I'll hand back now to Carol. And thanks very much. Just been really important to get this out to you and reach out and be safe, everyone. I'll speak to you in the Q&A.
Great, thanks so much, Pete. Inspection, identification, and environment, really is so important. We have some tips here for homeowners. Gosh, I learned a lot from this as well. And really, as we prepare for, potential bushfire, we usually clean out our properties, and we need to do the same, especially at the moment with all this rain. Really, mosquitoes are looking for water. So it's important that we inspect roofs for leaks. Keep an eye out for any leaking taps or any air conditioning units, and make sure that we keep up with our repairs and our home maintenance. It's important to talk to homeowners about cleaning out their gutters frequently, as the debris that clogs through there just provides more water flow into other areas on the property. And this is a key one as well. Throw away or store upside down any items that accumulate standing water. In particular, succulent pot plants. The mozzies love them. And I read this and then walked outside and realized I have them all outside my door, which is why I'm getting mozzies in the house. So keeping your property clean and clear of water. Clean your swimming pool regularly. Make sure you keep it chlorinated, and remember to keep those pool covers clean too. They also can collect little pools of water and debris, and also making sure that our sprinklers are well maintained as well. So there's just some tips for homeowners on mosquitoes. I just wanted to talk to you a little bit more on a few facts around Demand 100 CS. So points to remember is it's superior encapsulated lambda, so you get more from less. A 1 liter bottle, very economical. A 1 liter bottle of Demand 100 CS mixes 200 liters at the high rate, or 400 liters at the maintenance rate. So that makes it a great cost-effective general pest spray option for you. It controls ants, cockroaches, fleas, flies, mosquitoes, silverfish, and also spiders. It delivers residual control for up to 12 months indoors and also up to 3 months outdoors. It's cost-effective and long-lasting, and it's great to use both indoors and out, including foliage. So there's just a few points on Demand. Demand the best and kill the callback. Now going to move into the Q&A session. So let me just check the questions coming through. Now we have a lot of participants here today, so I'm sure there'll be some great questions coming through for Pete.
One of them is, how is a CS different to an SC? So I think Pete can probably answer that about the encapsulation.
Okay, encapsulated suspension is basically similar to a suspension concentrate, except it's encapsulated. It's that M&M technology. It's the chocolate melts in your mouth, not in your hand. It's this protective coating around the outside of the lambda or synthetic pyrethroid active ingredient. So it is actually in a little bubble of itself, so it's protected. And this is what makes basically a repellent, a non-repellent. It's not actually a repellent initially until that ball or casing actually cracks and opens up. So you're not getting this big amount of synthetic pyrethroid in the area to make it repellent. This is why you have to be careful when we're doing applications of the 4 mil per litre of lambda 100 CS in Demand. If we do it too strong, the insects sensitize it before they land and it's repelled away. So this is where the encapsulation really, really works well to keep those low doses. So once they land on it, it's too late. So this is where bifenthrin in the initial part can be too strong, and where we're not getting enough effect when it's later walked out, it's then worn out on the property. So we're getting this constant cracking of this encapsulation, which is this capsule suspension. So it works very similar to a suspension concentrate, but it's encapsulated and protected.
Perfect. Well, I think, Pete, you've also answered Campbell's question about whether it's a repellent. So Campbell, I hope you picked that up, that it is a repellent until it's not a repellent, or the other way around. It's a non-repellent until it becomes repellent when the capsule's open. And then there was another question here, Pete, about, and I think Carol answered that one, about what pests there are on the label that it's approved for. So Carol, if you want to just repeat that list that you had there, that would be great.
Thing. So it controls ants. There's a fair few of them around at the moment. Ants, cockroaches, fleas, flies, mosquitoes, silverfish, and spiders.
Thank you. Okay. So there's a few now in the Q&A, Carol. You can probably see those. Can you? Yep.
Yes, I can. Will there be staining on application surface, Pete?
No, this is a misnomer by most people. We test chemistries to twice their label rate to work out if they're going to stain. And the only way they stain is they leave a residual contact because they're mixed too strong. We're leaving residual insecticides, whether we're spraying it on wood, tile, concrete. You'll see it a little bit more of like a milky residue on glass, of course, because the glass isn't clean. You're seeing the residue a lot better. But when we see people staining, it's usually used when people go the old way down the avenue of giving you another elbow full. We don't want callbacks. The insecticides and formulations these days are different to what they were 20 years ago. So sometimes now less is best, as we do with our ant treatments, and we're not getting it. There is not really a product out in the market at the moment that actually stains. So when people are getting stains, you may see a little bit of a residual with powders, and those powders will keep moving. They'll just be dusted off. And then the active ingredient stays behind. But no, at label rates, at even double the label rates when we test them for the APVMA approval, they won't stain. It's just the surface they're applying to. And if in doubt, just check it out a little bit firsthand. And we're getting to a place in pest control now where 15 years ago, they didn't want to smell it. Well, now customers don't want to see it. So it's making it incredibly difficult for formulations to come up with new and better ways. We've seen some formulation changes that we've done with the ZC formulation with Demand Duo. These new formulations work really well and less active ingredient. So it's making things a lot more economical as well.
Great, thanks, Pete. There's another question in here. What's the benefit of the encapsulation?
Longevity. The insecticide isn't sprayed direct out to be exposed to water, dust, UV light, or anything else. So this encapsulation gradually cracks open over the next period of 2 to 3 weeks. The bigger molecules have a thicker encapsulation. The smaller ones have a thinner one. If you guys remember back, the old initial demand from Ron for Lunk didn't have an encapsulation, and that was brilliant on German cockroaches because they had a really great knockdown. Well, when we encapsulated, because that was one of our legacy companies, when we encapsulated it for Mozzie control, it wasn't working initially on Germans. Longevity, yes, but not the initial knockdown. And most people just want to see insects die straight away. They don't want to see an efficacious treatment within 2 to 3 hours. So that's one of those instances of having something to protect it. Also, it helps protect us. We know when we spray products around in the synthetic pyrethroids, we get sensitivity around our lips and our eyes. If we're not wearing respirators or in our skin, if we use it too much, we used to call it a bit of like deltamethrin burn. Bifenthrin on the slower end of the scale was not as sensitizing. That's what made that popular. But when we encapsulate, we're not actually then exposing ourselves as well. Even though we should use PPE, we're then limiting that exposure and we're not getting that spike from the synthetic pyrethroids, which we are very sensitive to.
And Pete, how would you describe the odor when sprayed? Is there a particular odor to look out for?
There is a slight odor as one of the carriers. It's linseed oil in the formulation, and it smells like someone's just oiled a cricket bat for about 10 minutes. But this is where we're getting away from when people used to say that, oh, you stank the house out and we had to go out for 4 or 5 hours. The odor dissipates. It's a low odor. It dissipates. So at least we know that we've sprayed, and probably within 15 to 20 minutes of a normal application at a normal knockdown rate, you wouldn't sense anything after about 10 or 15 minutes.
That's great, because Campbell feels that he asked, does it smell like boot polish? So he's cricket bats, boots, you name it.
Oh, it's just, and then that's a part of us as pest managers too. We sometimes don't sensitize it as much because we're exposed to it a lot more over our careers. So we become used to chemical smells or, those sorts of things. And the homeowner goes, oh, you didn't use that last time when you go back and do your next year's treatment. Different formulations are keeping things on the hop. And as I said, 15 years ago, we the homeowner used to go outside while we treated inside, but then we started making formulations that didn't have an odor, and then we got accused of spraying water. We can't win. Now they don't want to see it. We have to put down a residual insecticide for the insects to pick up if we're going to be offering 2, 3 month, 6 month warranties. And that's another conjecture that some people offer 12-month warranties. You're not getting 12 months residual out of most of these insecticides these days. And even if you use them at full strength, you still wouldn't probably get 12 months worth of residual out of them.
Yeah. Pete, somebody just needs a little bit more clarification. So around encapsulating the AI, does it affect the knockdown effect compared to an SC? So what's the speed of kill? So it's that fast knockdown versus the residual effects. What are we looking at there, please? Okay,
long-term residual is better with an encapsulated. The initial knockdown, because the protection of the encapsulation will give a hesitant, knockdown will be, starts cracking open within 15 to 20 minutes of being applied, those smaller molecules. So you'll see some results in 15 to 20 minutes. So fast knockdown, like a fly spray or a flushing agent, no, you won't see it. But long-term, that flushing agent won't be there after 2 days. So you won't have any residual. It's like using fly spray compared to a surface spray. You won't have any residual, so long-term. And that's the initial knockdown, but getting that efficacious treatment, and you're getting that support to support yourself for that 1 month, 2 month, 3 month service call. You're having that, encapsulation starting to burst open 2, 3 weeks later, and getting the remnant populations that may be hatching out of eggs or re-emerging mosquitoes that are now starting to lay again from the previous rainfall that happened 3 or 4 days ago.
And then, Pete, there's a suggestion here that we just explain a little bit more the difference between the species, like the Aedes vigilax that breeds in the salt marshes after spring and the tide events, and then also just the numbers of the pests that you can get within 10 to 20 kilometers close to those domestic dwellings. So it's just reiterating your point that you were making about the importance of identification. So if you could just tell a little bit more about the ID, that'd be great.
The ID is imperative, and I can't really go into different specific species here in Southeast Queensland because there are people from Victoria, there's people from Southeast Asia and on this talk, there's people from all across Australia. We need to go into our own areas. It's just like treating with species of ants or termites. We need to look at the species that are currently in the area. The Murray Riverland for Murray Valley encephalitis. There's no point in talking about dengue fever to the guys down there. So there's local, diseases inside those insects. If we know the insects in our area and the biology, which guys, I'd seriously suggest in Australia you join the Mosquito Control Association of Australia. That's mcca.org. And it costs $50 a year, wealth of information, wealth of knowledge from Australia-wide, because we have guys in Perth in the Peel area and Mandurah areas. So speaking of specific species like Aedes aegypti or Asian tiger mosquito or Vigilax is pretty nonsensical to some people in those areas. Find out in your own areas what the species of insect are, like your ants, like your termites. We don't have mastos in Melbourne. And, that's the sort of thing we have to look at. So finding those species and then identifying those species, whether they are, nocturnal or false mosquitoes in the Lockyer Valley, as I mentioned, that don't actually bite. Some people might have a flying insect problem, but they're not actually biting them. So understanding those species is a imperative thing. So sorry to the person that asked that question. If you'd like to email me or call me, I can speak to you about your specific area. I'd happily do that. But in different areas, like Cam in New Zealand at the moment, lots of people don't think New Zealand's got mosquitoes. It does have for a certain small window of the year, but we've got to look at those areas, and other areas like Southeast Queensland, we have them year round. So I don't want to bypass the subject. I'd just like to keep it sort of on topic because it's going to bore 65% of other people I talk about them.
Great. And then there's one more question here about, would you recommend using an IGR as well as a spray?
As a spray, probably not at the same time as a vector management spray. For other insects, yes, not for flying insects. So an IGR would work well on fleas and cockroaches and that sort of thing to back it up. And that's with, I I'd recommend a JHI, not a CSI. Chitin synthesis inhibitor works on the first instar, where JHI, juvenile hormone inhibitor, works on the cross sections of all the instars of insect breeding. So no, the best insect growth regulator is an adulticide. We kill the adults, they don't breed. But we have to back it up and support it with something else, and that's what lambda does with its encapsulation. It's still in the environment 2 to 3 months later. So when we do get eggs hatched at the next rainfall, we still see, as you see by that JCU trial, we still see that knockdown when it comes across to a water or an incursion of blown in mosquitoes from a southern weatherly change. It actually knocks down because that lambda is supported with really good residual in that environment.
Perfect.
Some excellent questions there. I love all the engagement that's coming through in the chat and also in the question box. We've had a tech talk on fire ant, and we've also had a tech talk now on mosquitoes. Drop in the chat if there's another particular topic you'd like us to cover for you. I think that might be us.
I'm sorry, and Campbell did just ask, should it not smell once it's dry, Pete? Is that usually what happens with the spray?
15 minutes. By the label, the people aren't supposed to be inside the property if you're spraying inside a house or whatever. Within 15, wait till it's dry to the part, that way. But within 15 minutes to 20 minutes, it's flashed off and evaporated. It's open up the building, let it dry quicker. It's not a big issue. I have constant I have constant phone calls from people who ring me who don't pay for their chemicals and say it stains. And we've got guys using it at 4 or 5 times the label rate. I love the sales, but we don't need to do it. It's just wasting chemistry. It's wasting, and it's just being uneconomical. The chemistries these days, as I said with our ant treatments, we know less is best. We're not having to knock them over. We want the ants to transfer the products like indoxacarb back to the nest. It's really, really good. So less is best. The ants do more treatment. So these formulations are really supporting us. We've got over the problem or the initial, problem, or people say we're not getting good knockdown with demand and we're doing demand 100. That's why we developed Duo. It's got the knockdown of thiamoxophthalm in it. So it gets a really, really good initial knockdown, and the lambda that's encapsulated backs it up for the next 2 to 3 months. So you're not getting any service calls. It's formulation chemistry, and that's a ZC formulation. So it's not even an SC formulation as John put out before as well.
Sorry, and one last question before we wrap up, Pete. Just asking whether lambda controls mosquito larvae and the eggs as well, or is it just an adulticide?
It's an adulticide. We can't get chemistry through eggshell. That's Mother Nature's protection. So that's a part of these misnomers. If we've got something, this is probably where the question came up about an IGR. Insect growth regulators have a longer residual than synthetic pyrethroids. So that's why for flea treatments and carpets and stuff like that, you back it out. But once you go outside, it's not really worth it doing it because it's going to be broken down by the environment. And just one quick one to support that, Jonathan Damrow from the Mosquito Control Association and QMIR has just said the false mosquito isn't a mosquito. Correct, John, you're right.
Yeah, and John also kindly pointed out that our pick was a crane fly, not a mozzie as well. So we'll have to update that on our Prezzo. So thanks. That's why we got you people here as well. Okay. Thanks, everyone, for your attendance. Carol, do you want to wrap up?
Thank you so much for joining us today to understand more about mosquito management and about the identification and the treatment in the environment. So make sure that you check out what you're doing, remove some of those water sources, pick up a bottle of Demand 100 CS. It's very economical and available at all your distributors out there. Thank you so much for joining us today. Again, please do pop in the chat if you've got an idea that you'd like to see more talks from Pete about. Very interesting, and thank you again for your attendance today. All the best.
Be safe, everyone. Please be safe. Speak soon.